So I'm just going to try and get it to work. All right. Remind me, what formula do we already know that talks about exponential growth? Compound interest. All right. So when we talked about compound interest, or what was the other one? Decay, right? So exponential growth or exponential decay are the words that we're going to be using. These are called exponential graphs. How do you recognize the equation? Right, x is the power. Excellent. So whatever number is there, the power is x. So you might have y equals 2 to the power of x, or y equals -4 to the power of x. Whatever it is, x is the power. If it's a growth model, it's going to climb exponentially. If it's a decay model, it's going to sadly decline over time, right? So when we're talking about any equation where x is the power, if it's positive, it's going to look like this. If it's negative, it's decaying. Can you just have a look at page 440 for me? Page 440. Yeah. It has a really lovely summary of all the different graph shapes. Can you see that? So we've already been talking about them. We need to be able to recognize what the different shapes look like based on their equations. So you can see that they've got linear, quadratic, reciprocal, which is also known as a hyperbola, a cubic graph, exponential, which is what we're talking about today, and combined curves. So that last one is a bit weird because it's when you mess things up and put them together, you can get some pretty weird shapes. So if your equation, like some of the stuff we did in the last exercise, if you get some pretty weird shapes, but you can see that it's multiple types of equations, that's okay. So today you're going to be using table of values to graph exponential things and make predictions from the graph, right? So if I have things like, if I have a graph that grows and it does that, and I'm asked, so let's say that these are years, right? Well, let's pretend that that's good. And let's pretend that these are thousands of dollars, right? So that's $1,000, $2,000, $3,000. It's 1 year, 2 years, 3 years, 4 years. If I was asked how much money will I have after 4 years, I'm just going to read it off the graph like this, right? I'm going to say I will have $3,000 after 4 years. Can we not? Let's focus. All right. So you're not being asked to find exact values. You're being asked to use your graph to predict future values. Now, the one new thing we are going to do today is tangents to a curve. So if I close this, I won't be able to do it again. I don't think I need this anymore. Okay, so let's have a look at tangents to a curve. Are actually not that hard, but they are still approximate. All right. So if I have my nice little graph here, I'm going to use this instead of trying to draw it because I'm always so bad at that. So let's say y equals x squared. Oh, why isn't it typing? X, there we go. X squared minus 3. Okay, so if we have this graph, I'm just going to zoom in a little bit. If I am asked to draw, so one of the things you're going to be asked, boys, we need to be paying attention. This is a new thing. We're going to be asked to draw a tangent line to the graph at a point. What's the definition of a tangent? No, not the tan ratio. What's the definition of a tangent line? Do we know? A straight line? It's definitely straight. It touches the curve, right? So it doesn't go through it. It touches the curve and then goes away again. So if I am asked to draw a tangent line at x equals 1, what I do is I find where x is 1 and I get my ruler out. I am going to get a straight line tool though, because that's the stamp. Where is my straight line tool? There we go. And what I'm going to do is I'm going to draw, okay, a tangent line. So you can see that touches the curve, but doesn't go through it. And now what I want to do is something we already know how to do, is find the gradient of the tangent line. How do I find the gradient? Rise over run, right? So what I'm going to do is I'm going to pick any 2 points on my line. I've already got one. This point here is 1, -2, right? Where x is 1, y is -2. I'm going to pick any other point. I'm going to pick this point because I can, right? This is 3, 2. So how far am I rising between -2 and +2?
4.
4. And how far am I running between 1 and 3?
1.
All right, so that means my gradient is 2. Okay, so you've got to be accurate with this. Make sure you get your ruler out, you draw a really good straight line, and then you're just counting rise over run. For those people that started to say the fancy formula, what's the fancy formula with coordinates?
Oh, x1 minus y. No,
So close.
Minus y, x2 over y2. No, y2.
Good, okay, it's backwards. Y2 minus Y1 over X2 minus X1. Because this bit, are we listening? This bit, the Y is the rise, and this bit, the X is the run. So let's do that and make sure it works. So I'm going to put in Y2 minus Y1. So that's 2 minus -2. Guys, come on. So it's 2 minus -2, which is 2 plus 2, which is 4, over, and then I've got x2 minus x1, which is 3 minus 1, which is 2, which is 2. So we get the same answer either way. I don't mind which way you do it. They both work. So you're getting your curves, you're drawing a tangent line at whatever point they say. They will tell you where to do it, and then you just count the gradient. If the line goes this way, what's the gradient going to be? Negative, okay? So negative gradients go this way. Make sure you pay attention to that. All right, today we are doing lesson 6, which is 18.9 and 18.10.
Don't forget to subscribe and like the video.
Thank you, Samriti.